long will it take us to reach the moons of Jupiter? Approximately 100 moons orbit Jupiter, but the most intriguing are known as the Galilean satellites. They were named after Galileo, who first used a telescope to observe Jupiter's satellites in 1609. Since then, astronomers around the globe have been captivated by these moons, attempting to determine their composition and physical characteristics. Numerous fascinating discoveries have been made, including the existence of oceans, glaciers, volcanoes, and geysers on their respective surfaces. The recent detection of CO2 on Europa, one of the Galilean moons, by the James Webb Space Telescope may have far-reaching implications for the search for extraterrestrial life. How long would it take a spacecraft to reach Jupiter and investigate its moons? The answer depends on several variables, which you will learn about in this video. But before we go, subscribe to our channel and ring the bell so you don't miss any update. How long does the journey to Jupiter take? The journey to Jupiter in the vastness of space is a feat that requires meticulous planning and innovative propulsion techniques. Multiple missions have been launched, each employing a unique trajectory and propulsion technology. Some missions, such as NASA's Juno, choose a direct path. These spacecraft, which are endowed with powerful engines, take a direct route to Jupiter. This trajectory is rapid, requiring roughly 13 to 14 months to reach its destination. It is comparable to a sprinter racing towards the finish line, relying solely on speed to attain its goal. However, others, such as the Galileo spacecraft, choose a more complex path. They obtain momentum by utilizing the gravitational pull of planets such as Earth and Venus. This method typically extends travel duration by 5 to 6 years. It is comparable to a clever hiker who uses the terrain strategically to cover a greater distance. The Jupiter Icy Moons Explorer (JUICE) mission exemplifies the use of solar electric propulsion, which is a distinctive approach. This method uses the energy of the sun to generate propulsion. Despite being slower than conventional engines, it offers sustained acceleration over time. The JUICE mission, which will last 7.6 years, exemplifies this patient and effective approach. Comparing these methods of propulsion reveals their distinct characteristics. Conventional engines with direct trajectories generate rapid acceleration, comparable to a sprinter's burst of speed, swift and potent, but fuel-intensive. However, gravitational assists demonstrate the art of using natural forces to acquire speed. It is comparable to a hiker skillfully navigating the terrain. It takes longer, but it conserves valuable fuel, making it a strategic option for protracted missions. Ultimately, the use of solar electric propulsion is a sustainable and patient strategy. It utilizes the mild but constant propulsion of charged particles, comparable to a marathon runner. Although slower, it maximizes efficacy and reduces fuel consumption. However, the planning of a mission is heavily dependent on its objectives. If you wanted to simply place the spacecraft in orbit around Jupiter, it would be quite simple. Even though reaching Jupiter has never been simple, modern space agencies strive to maximize the impact of their missions. For instance, it would be delightful to observe Jupiter and its moons simultaneously. Do you believe it to be impossible? Actually, you are mistaken. The concept of a grand voyage of Jupiter's moons has existed for decades. Imagine packing up and leaving everything behind in order to travel to a faraway country. Wouldn't it be great if you occasionally stopped along the way to converse with the locals and learn about their culture, or just to snag a bite to eat so you can continue? Modern missions to Jupiter attempt to accomplish something similar. Obviously, the trip will be a bit longer than usual, but the quantity of knowledge and discoveries that could be gained by intelligently planning this grand tour would be enormous. This is the sort of trip we wish to discuss in this video. We want at least an estimate of the duration of such an unforgettable journey. And fortunately, there is a NASA mission that will accomplish this. It is called JUICE, and it is one of the most crucial missions of this and the following decades. The objectives of a mission have a significant impact on its planning. If the only objective is to place a spacecraft in orbit around Jupiter, the task would be relatively simple. Despite the difficulty of reaching Jupiter, modern space agencies endeavor to maximize the potential of their missions. An ambitious objective is to simultaneously observe Jupiter and its moons, a seemingly impossible concept. However, the concept of undertaking a grand survey of Jupiter's moons has been pondered for decades. First part of JUICE trajectory. and it will do so by utilizing the trajectory currently visible on the screen. This animation depicts the JUICE spacecraft's voyage to Jupiter. The proposed trajectory of JUICE is shown as a white line commencing within the orbit of the Earth, shown in blue. By tracing the trajectory, it is possible to comprehend the gravity assist strategy employed during the 88-month cruise phase of the mission, a series of flybys of Earth, Venus, Earth, Mars, and again Earth. Our spacecraft will be alone in interplanetary space for more than 7 years, or 88 months. And that is only the time required to reach Jupiter. Later, when JUICE is finally ready to fly by the moons and execute an orbit insertion around Ganymede, the fun will begin. As JUICE begins its initial elliptical solar orbit, its distance from the Sun decreases. According to Kepler's second law of planetary motion, this causes an increase in speed, and the spacecraft overtakes Earth. During this first orbit, JUICE reaches its maximal speed at perihelion, when it is closest to the Sun, but its speed decreases as it approaches aphelion. Earth will have caught up with JUICE by the time the first solar orbit is complete, allowing the first gravity assist maneuver to be executed. At this juncture, the spacecraft is deflected toward Venus, whose orbit is depicted in yellow, and accelerates as it falls toward the Sun. Importantly, orbital angular momentum is conveyed from the planet to the spacecraft during each planetary flyby. The acquisition of planetary angular momentum is the key to the flight strategy and causes JUICE to accelerate further. The JUICE spacecraft will not have sufficient fuel for a direct journey to Jupiter upon launch. Therefore, a series of planetary flybys will be required for the spacecraft to acquire sufficient energy to reach its destination. After passing Venus, JUICE will make additional flybys of Earth, Mars, whose orbit is depicted in red, and Earth before its October 2029 rendezvous with Jupiter. The animation concludes at the point of insertion into Jupiter's orbit, so only the first set of gravity assist maneuvers choreographed by ESA flight dynamic specialists are depicted. After this phase, JUICE will conduct a total of 35 lunar flybys. This will require effort. However, how long exactly? I will shortly explain this to you. JUICE trajectory, second part. When JUICE arrives in the Jovian system in July 2031, its pace will be 5.7 kilometers per hour. This velocity is too great for the spacecraft to remain tethered to the system. Therefore, mission analysts plan to conduct a first flyby of Ganymede at a distance of 400 kilometers in order to reduce the velocity by 300 meters per second. Approximately 7.4 hours later, the spacecraft will use its main propulsion to slow down by an additional 900 meters per second, allowing it to enter an elliptical orbit around Jupiter with a period of 272 days. After the initial orbit, and while still utilizing Ganymede's gravitational assistance, the period will be shortened to 57 days, and then to 36 days, using the same maneuver, making the orbit around Jupiter nearly circular. During the mission, only 2 flybys of Europa are anticipated. These will occur promptly following the first flyby of Callisto, originally scheduled for July 2032. Now listen carefully, because this is insane. For the Europa flyby to occur under optimal lighting conditions, the speed resulting from the Callisto flyby must be calibrated to within a few meters per second. This is the level of precision that NASA engineers can achieve. The spacecraft will use Callisto's gravity to increase its inclination with respect to Jupiter's equatorial plane to approximately 26 degrees, allowing it to investigate the polar regions of the gas giant's atmosphere. Returning JUICE to an orbit around Jupiter will require 3 new flybys near Callisto, followed by 10 subsequent flybys of Callisto. However, here comes another issue. At this point, JUICE's speed relative to Ganymede is approximately 3.8 kilometers per second, which is too rapid. If it had sufficient propellant, it could reduce its speed to the desired level, but it does not. Therefore, engineers intend to minimize it using the gravitational assistance of Ganymede, then Callisto, and then Callisto again. At that point, its relative velocity will have decreased to 1.6 kilometers per second, and a final gravitational assist from Callisto will enable it to adjust the inclination of Ganymede's orbital plane with respect to the direction of the Sun. Over the course of 11 months, these maneuvers will be used to investigate the plasma and magnetosphere present between the Jovian moons. The orbit intersection around Ganymede is a crucial aspect of the mission, as the primary objective of JUICE is Ganymede research. In 2034, JUICE will be the first spacecraft to orbit a moon other than Earth's for a duration of 3 months. Mission completion and duration estimation. After the propellant is depleted, JUICE will be deorbited and is expected to impact Ganymede in September 2035. As you can see, mission planning for Jupiter and its moons is no easy task. According to JUICE's Grand Tour plan, such a journey would require at least 10 years. Obviously, our understanding of the solar system will be eternally altered after JUICE. Alright guys, this video ends here. Thanks for watching. Do you believe 10 years is a sufficient quantity of time to explore Jupiter and its moons? Share your thoughts in the section below. Subscribe to the channel and I'll see you on the channel again soon.